Welcome back. In the last video, we came up with four patterns that developed when we did the expansion, and we need each of these patterns in order to do or complete the binomial expansion. So what we're trying to do, the ideal goal here is we want to take this expansion and we want to end up with this answer. And the benefit, or what we really want to head towards, is being able to do it with doing it in one line. So I want you to be able to do this expansion. I want you to do this huge expansion, and I want you to be able to jump to final answer rather than do the intermediate steps there, and you're going to be able to. So there's a couple things we need to know. We know that the x terms, or the first term in each case, increases by 1 up to the max, or sorry, decreases down to 0. The second term starts at 0 and increases. The coefficients for our expansion, they are all found inside Pascal's triangle, and the exponents always add up to the total. So we'll do some examples here so you get to see firsthand. So the first thing I'm going to do, I need a bit of a Pascal's triangle off to the side here. So I'm going to draw it out and I'm going to shrink it down. So if you have a Pascal's triangle previously made, you want to have it in front of you. So 10, 10, 5, and 1. 0, 1, 2, 3, 4, 5. I need one more row because I went out to the 6th. Oops. So if I shrink that down, because we need it for a reference, group that, shrink it down. I'm going to put it up in the top corner here. Try to get it out of the way. So remember the row numbering. So I'd have 0, 1, 2, 3, 4, 5, 6. So I'm going to need that 6th row, and the reason I need the 6th row is because this question is to the exponent 6. So I want to do this expansion in one step. Okay? So first thing I'm going to do is I'm going to write out the coefficients from the 6th row. I'm going to space it out so that it fits across the page. You want to leave yourself some room. So 1, 6, 15, 20, 15, 6, and 1. The next thing is to take your first variable. So the first variable is x. And we want to write it in each one. So everyone gets an x. And we know that that first variable starts with the biggest exponent, so it's going to start with the 6, and it's going to decrease by 1. So 6, 5, 4, 3, 2, 1, and 0. Now we want to take the second variable, the y, and each term gets a y. And the exponent on the y is going to start at 0 and go the opposite way. So 0, 1, 2, 3, 4, 5, and 6. And the last thing, because it's addition, because we're adding, all we are going to have is plus signs. So we put plus, 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 and plus. And now we just got to clean it up and simplify. So remember, anything to the exponent 0, way back to grade 9, so x to the 0, anything to the exponent 0 is always 1. So when we clean this up, y to the 0 just becomes a 1. We don't usually write the 1 in front, so this is just x to the 6th plus 6x to the 5th y plus 15 x to the 4th y squared plus 20x cubed y cubed plus 15x squared y to the 4th plus 6x y to the 5th, and again y to the 0 is just 1, y to the 6th. So you just took x plus y times x plus y times 6 times, and you expanded it or factored it out or expanded it out in 2 steps. And really the second step is just cleaning up. It's really that first step, that expansion. You're done. That's all there is to it. So what's the difference when you have a number? So if we look at the next example here, we now have x plus 2 to the 4th. So how does a number change what we are doing? So we do the same thing. So the key information here is we need to use row 4 from Pascal's triangle. So I go up to my Pascal's triangle in the top corner, x plus up here, sorry. That's where I'm going to get my coefficients, 1, 4, 6, 4, 1. So I'm going to write those out, and I'm going to space them out. 1, 4, 6, 4, and a 1. Each term is going to have an x, and it's going to start with the exponent 4. So x to the 4th, so I'm going to do 2 steps at once. X cubed, x squared, x to the 1, I'll put the 1 in, and x to the 0. Next, every term is going to have a 2. And the exponent starts at 0. So 2 to the 0, 2 to the 1, and I'm going to put brackets in here. Just it looks a little cleaner. 2 squared, 2 cubed, and 2 to the 4th. Again, we have adding this time, so it's still adding. So everything's going to have a plus sign in between, so you add your adding signs in between the terms. Now note there's going to be, we're doing row 4, so there's 5 terms. If you look at the one above it, we had row 6 out of Pascal's triangle. There's actually 7 terms. So this one takes a little bit more with the calculator. Okay, some of us can do it in our heads. 2 to the 0, anything to the 0 is a 1. So we have 1 times x to the 4th, so it's x to the 4th, plus. Now in this case, 2 to the exponent 1 is 2. You need to multiply it with, like terms are the numbers, so 4 times 2 is 8. So we get 8x cubed. 2 times 2 is really a 4, so 4 times 6 is 24x squared. And 2 cubed, that's really 8. 8 times 4 is 32x. And then 2 to the 4th is 16. And then again, the x to the 0 goes to 1, so 1 times 1 gives you your final term. So there you go. You just did 2 expansions. That one, x plus 2, x plus 2, x plus 2, x plus 2. You expanded out, and you really did it in one line. And the second line is just cleaning it up. So it's just using that those properties. So when you are looking at it in terms of a pattern, it's basically just working your way through and multiplying the term that comes up with the coefficient from Pascal's triangle. Now remember, for some of us, Pascal's triangle, if you do not want to go through and write it out or memorize it or put it on your cheat sheet, remember you can simply just write it as a combination. So 0, 0. If we look at the second example there, the 4th row, so 0, 1, 2, 3, one more. I could have just, instead of looking it up or writing it out like I did in the top corner, I could have just wrote it as 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. Those numbers then, those are the same as the numbers I used up here in the expansion. That is exactly what it is here for 1, 4, 6, 4, 1. So you don't have to use Pascal's triangle. You can use combination notation. Most people are going to have that Pascal's triangle on their cheat sheets, so they'll probably end up using it. So in general, the binomial theorem looks like this. So if you have x plus y to the exponent n, so we're talking about any expansion now, you can simply write it as, and the reason I showed you that previous slide down here is because when I do the general formula, okay, when I do this general formula, it's easier to do it in that notation. So what it just says is that n choose 0, x to the n, y to the 0, plus the next term would be, using combinations, n choose 1, the x exponent goes down by 1, and the y exponent goes up by 1. And that will continue until you get to n choose n, so the last one term in Pascal's triangle in that row, when the x exponent becomes a 0, and the y exponent becomes an n. So that is the binomial theorem. That's the actual formula. And that's the one that you can put on your formula sheet, and you're just substituting values in because the n is located here for you. So n, it's not like you're going to search for it. Same thing here, there's an n, it's all given information. So the formula does work. A couple of quick examples here. So I'm looking at number 1 here. Determine the missing value for the expression of 3x minus 2y to the 5th. So if you look at the first one here, we are missing the exponent on the x. Now remember what I said from the previous example, and if you look at the previous one here as well, we'll see that the exponent, when you're dealing with variables, always adds up to the original. So x to the 5th plus y to the 1, 5 plus 1, gives us 6. So we're just adding up the exponents to make this work out. So we know that the exponent on the y is 1. So we know that a plus 1 is equal to, and it's got to be equal to 5. So it has to equal 5. So therefore, a must be 4. And you can jump to final answer. These aren't meant, I'm just showing you the steps. So 2 plus b. So it doesn't matter what term in this expansion you're looking for, whether it's the first term, the last term, the middle term, the exponents always have to add up. So b would have to be 3. And the last one, c plus 4, has to equal 5. So c must be equal to 1. How many terms are in the following expansion? So question number 2. Remember that Pascal's triangle, no matter what row you're in, okay, there is one more term than the row number. So for the row at the top here, look at this, okay, we see that 1, 2, 1, okay, it's row 2, but there was 3 terms in it. So when we go back to this question, we're interested in row 9, so it's row number plus 1. So therefore, there's going to be 10 terms in this expansion. In this case, there's 22. So 22 plus 1, you're going to end up with 23 terms if you were to expand this out in full. So it's just your row number, or the exponent, and plus 1, and that tells you how many terms. Finally, we want to do some factoring here. So with the factoring, I'm going to finish that up in a final video because it takes a little bit more time to explain. So I'll leave it at that for now, and I'll finish that up in the last video.